All right, so we're beginning to solve equations. So the question is, what does it mean for there to be a solution to an equation? So the definition of what it means to be a solution means, let me give an example. Solution means that there is a value for the variable, in this case it's x, there's a value for the variable that when plugged into the equation creates a balanced equation, meaning that the left and the right-hand side are equivalent, are absolutely the same. When we look at both sides of the equation after doing the arithmetic, when we plug the solution back in, both sides should look exactly alike. That's why we call that scenario an identity, okay? When one side of the equation looks exactly like the other side of the equation, it's called an identity. So a solution is a value for the variable that creates an identity out of the equation. So for instance, we know just intuitively that x needs to equal 4 here, because 4 plus 5 equals 9. Since x equals 4 is the solution, x equals 4 is the solution. So if you were to write the solution down on your quiz or test, you would write x equals 4 and put a circle around it, okay? By the way, you could say 4 equals x as well. Traditionally, we put the variable on the left-hand side of the equal sign, but in order to prove that x indeed actually is 4, you need to plug it back into the equation. So since we now know that the true identity of x in this particular equation happens to be 4, I should be able to plug 4 in for x and create an identity. So 4 plus 5 is 9. Oh, and look, 9 equals 9. When you have the left-hand side look exactly like the right-hand side, you've created an identity. This is what an identity is. Like when you look in the mirror, you're looking at yourself. So when this 9 is looking at itself, there's nothing else here. And we have shown that 4 indeed is the true value of x in this particular equation. So in order to find out or to check or to prove whether the value that you get for a variable is indeed the solution, meaning you didn't do any wrong arithmetic to get to it, in order to prove that, plug it back in. The plugging back in we call substitution. So when you substitute the value back in for the variable and you do the arithmetic, you should create an identity. So that's how you can check. So if you're given, for instance, let's say 3x minus 5 equals 15, okay? So what you'll do to, let's say that you want to solve this equation, okay? You would add 5 to both sides because you want to keep this equation balanced and you want to get x isolated. So then that would be 3x equals 20. 3 times x needs to be broken apart. The way that you break apart subtraction is with addition. The way that you break apart multiplication is with division. So you divide it by 3. Whatever you do to one side of the equation, you have to do to the other because it's a balanced equation. So x equals 20 over 3, okay? We are claiming that 20 over 3 is indeed the true value of x in this particular equation. So let's plug 20 over 3 back in for x and see if an identity results, okay? So we're claiming that x equals 20 over 3. That's what we're claiming. We're claiming that 20 over 3 is the solution. Okay, let's see. All right, so instead of saying 3 times x, let's say 3 times what we are claiming the solution to be. It's 20 over 3. So that's going to be 20 divided by 3. Instead of 3 times x, is going to be 3 times our value for x. Minus 5 equals 15. Let's see if this creates an identity. 3 times 20 over 3, that's 60 over 3 minus 5 equals 15. What's 60 divided by 3? 3 goes into 60 how many times? 20. 20 times. Okay. So that's 20. What is 20 minus 5? 20 minus 5 is 15. So this side is 15. What is this side? Oh, this side is also 15. It creates an identity. So we have just proven that 20 thirds is indeed the true value of x in this particular equation. So I'll have you go and test out some possible solutions, some candidate solutions, and then you can tell me whether these candidate solutions are the true solutions or whether they are incorrect and something else should have been the solution instead. Okay, thanks.